In this video, we're going to be talking about repeated zeros. So we're basically going to be analyzing polynomial functions, and then we're also going to find a polynomial function with given zeros. So let's start by taking a look at our repeated zeros information. So for a polynomial function, a factor of x minus a raised to the k power, where k is greater than 1, is going to yield a repeated zero, where x equals a, with the multiplicity of k. So if k is odd, then that's going to tell us that the graph is going to cross the x-axis at x equals a. But if k is even, then that tells us that the graph is going to touch the x-axis but not cross it at x equals a. So we're going to go ahead and we're going to do an example of this, where we're going to find all real zeros, all the real zeros of f of x equals x to the fifth minus 3x to the third minus x squared minus 4x minus 1. And we're going to use the zero feature on our graphing utility to do that. So what that means is we're going to pull up our calculator, and then we're going to go to our y equals and plug in our equation. So we have x to the fifth minus 3x to the third minus x squared minus 4x minus 1. And once we put that into our calculator, we're going to hit graph. So here we see that it's crossing 1, 2, 3 times. And so what we're going to do now is we're going to use the zero feature of our graphing utility. So to do that, we're going to go to second, trace, which is our calculate menu, and we're going to go to option number 2, which is 0. I'm going to hit enter. And it says left bound. So we need to decide which zero we're going to do first. So I like to start on the left and then work my way to the right. So I'm going to move my cursor all the way over here on the left-hand side of my 0. So I'm going to move that over. Oops, a little bit too far. There we go. And so I see that my dotted line is really kind of hard to see it right here, but it's on the left-hand side of my point. Then it wants the right bound, so I'm going to arrow over. So I'm on the right side of that, and so I see that my 0 is between those two dotted lines. And then I'm going to hit enter, and it's going to tell me that my 0 is negative 1.86, comma 0. So let's go ahead and write that down. So we have an x value of negative 1.86, and now we're ready for our next x value. So we're going to go to second, trace, go to option number 2, and now we're going to find our next 0. So here I'm going to go ahead and enter, and then I'm going to hit enter again, and again my 0 is between my two left bound and right bound dotted lines. I hit enter, and I see that here I have negative 0.254 or negative 0.25 comma 0, so we can go ahead and write this 0 down as well. And so now we're ready to find our last 0. And so we're going to go ahead and go to second, trace, choose option number 2 to find our 0. And I'm just going to get a little bit closer. It doesn't really matter. So left bound. And I'm going to arrow over. I'm kind of far away, but that's okay. Even though you can't see me, when I hit enter, I see that I'm between the two dashed lines, really close to this one, but that does not matter. I'm going to hit enter. And here I'm going to see I've got 2.11. And then here I've got 1.4 e to the negative 12. Well, that means that there's 11 zeros in front of the number 1, so that's pretty much a 0. Remember when we do this, the calculator asks us, are we ready to have it guess? Because it's an estimate. So we're going to put down 2.11 as our third 0. And so here we have our 3 zeros for our function. So let's look at how can you determine what the polynomial function would be with specific given zeros. So I'm going to make that a little bit bigger. So here we're going to find a polynomial function with the zeros, negative 1/2, 3, and 3. And that's not a typo. It's supposed to be a 3 and a 3. So what we're going to do is we are now going to create these zeros. So here, this negative 1/2 is telling us that we're going to have x plus a 1/2 for a factor. But we don't want fractions. So what we're going to do is we are going to multiply everything by 2. So multiply that by 2, multiply that by 2. So that way that fraction goes away. And it's going to give us 2x plus 1. So that's what we're going to use for this 0 right here. So now for this 0, there's 2 of them and they match. So here we'd have an x minus 3. Now we pick our symbol based off of the opposite of these values. So because these are positive, we know our factor needs to be a minus. Well, how do we know that? So we know that because if I took x minus 3 equals 0 and I solved, I would get that my 0 was 3. And so that's how we decide to use that. And that's how we know. Now, how many 3's are there? There are 2 3's. So that 2 is a power right there. Now, there's lots of different answers that you could have for this. This is just kind of the simplest way to do it. So now, we're going to take our 2x plus 1, and we're going to take our x minus 3 quantity squared, and we're going to multiply those. So what I'm going to do is, when we look at this, we see that we need to FOIL it if we're trying to multiply things out. And so if I have x minus 3 times x minus 3, then I have x squared minus 3x minus 3x plus 9, which gives us, x squared minus 6x plus 9. And so that is what we're going to put, this is what we're going to put right in that spot. So we have 2x plus 1 times x squared minus 6x plus 9. Now from here, we can just do some simple distributing. So we're going to take the 2x and we're going to multiply to all 3 pieces. So 2x times x squared is 2x to the third. 2x times negative 6 is a negative 12x squared. And 2x times 9 is going to be a positive 18x. Then we're going to do the same thing with the 1. So we'll go to each piece. So to the x squared gives us an x squared. To the negative 6x will give us a negative 6x. And then 1 times 9 is 9. And now we just need to combine our like terms. And so looking at this, we see that there's not another 2x to the third. So we can write 2x to the third down. But we do have a negative 12x squared and a positive 1x squared. And so that's going to leave us with a negative 11x squared. Then we're going to see that we have an 18x and a minus 6x. So that's going to give us a 12x. And then lastly, we have our plus 9. And there's nothing to put with that one, so we can put it there. And so now we have a polynomial function. So we can say that f of x equals 2x to the third minus 11x squared plus 12x plus 9. And any multiple of this would also be considered a correct answer. And again, we decided to take the fractions out just to make it an easier problem to do. You could leave them in, but it gets kind of messy.